Let's practice finding the volume of a rectangular prism that has some rational edge lengths, where their side lengths are actually fractions or decimals perhaps, and we're going to go ahead and do this using fractional cubes as well, or cubes that have fractional edge lengths. In this particular example, we're going to be dealing with a rectangular prism, where the length of this rectangular prism is going to be 5¼ meters long, the width is going to be 6 meters long, and the height of this rectangular prism is going to be 2¾ meters long. While we're going to figure out the volume of this rectangular prism, we're also going to see how many of these 1/4 by 1/4 by 1/4 meter cubes are going to fit inside of this rectangular prism. So these are going to be some pretty small cubes relative to regular 1 by 1 by 1 meter cubes. Let's just go ahead and start by making a sketch of this 3D figure and figure out the volume of this rectangular prism. Alright, so now that we have a sketch of this rectangular prism, this 5¼ meters, this is going to be the length going across the bottom. Then we have this 6 meters, that's going to be the width, that's going across the bottom as well. It's part of one of the dimensions of the base. And then we have the height here, that's going to be how tall this rectangular prism is going to be. Now what's our formula for volume? Now for volume of rectangular prisms, or prisms in general, that's going to be the area of the base, capital B, multiplied by the height. Now in this particular case we have rectangular prisms, so the base is going to be calculated by multiplying the length and width together, then multiplying by the height. So then this is going to be, we can substitute the length is going to be, let's see, 5¼ So let's go ahead and write 5¼ That's going to be meters. And we're going to multiply that by the width. The width is going to be 6 meters. Let's substitute that in as 6 meters. And then finally, we're going to multiply this by the height. The height is going to be 2¾ So 2¾ and that's going to be meters. So we can multiply these three values together, dimensions, to get the volume. Now let's go ahead and rewrite these as improper fractions. So 5¼ is the same thing as 21/4, okay? And then we're going to go ahead and multiply this by 6. Now that's going to be 6/1. It's going to be 6/1 meters. We're going to multiply this by 2¾ which is the same thing as 11/4. So 11/4 meters. Since we're multiplying here, it looks like we can cross cancel a little bit. So 4 and 6 can both divide by 2. They're GCF, so we're going to be left with 2 and 3. But I think that's just about it there. So in the numerator, if we go ahead and we multiply, 21 times 3 is going to be 63. 63 times 11 is, I believe, going to be 693. So the volume here is going to be 693 for the numerator. And then for the denominator, we're going to have just 2 multiplied by 1 times 4, and that's going to be 8. Okay. If you go ahead and do some long division here and see how many times 8 fits into 693, I believe you're going to find out that fits in 86 times with 5 left over, so that's going to be 5/8. And we have what for the units? We have meters times meters times meters, so we're going to have meters cubed, and so 86 and 5/8 would be the volume of this rectangular prism in cubic meters here. All right, now that we know what this shape looks like, let's see if we can actually figure out what the volume is and use these little smaller 1/4 by 1/4 by 1/4 cubes to fill up this prism. So again, here is that rectangular prism that we are talking about. Let's talk about method 1, where the number of these 1/4 by 1/4 by 1/4 meter cubes that fit inside of this rectangular prism is going to be equal to the volume of the entire rectangular prism divided by the volume of 1 unit cube. So what does one of these little cubes look like, and what is its volume? So this is what one of those little cubes would look like, and if you wanted to find the volume of it, it would be the area of the base times the height, or length times width times height. Because it's a cube, all three side lengths are the same, so it's 1/4 by 1/4 by 1/4. Now in the numerator, 1 times 1 times 1 is going to be 1, and then the denominator, 4 times 4 times 4 is going to be 64, and this is going to be 1/64 cubic meters is going to be the volume of one of these little cubes. So if we wanted to go ahead and figure out the number of how many of these little cubes would fit inside of this rectangular prism, we could take that total volume that we found out earlier. That total volume was 86 5/8, but we know we're going to be dividing here, so let's just go ahead and use the improper fraction version. So that's going to be 693/8. That's going to be the volume. I'm not going to write the units right now. Let's go ahead and divide that by the volume of one of these cubes. So the volume of one of these unit cubes is just going to be 1/64. Again, I'm going to leave the units off for now. Let's go ahead and put them in a little bit. It's going to be 1/64. And let's see what this is going to turn into. If we're dividing fractions, we can go ahead and multiply by the reciprocal of the second fraction. So 693/8 multiplied by 64/1. Okay, and it looks like we can maybe cross cancel here a little bit. So 8 and 64 can both divide by 8. So 64 becomes 8 and 8 becomes 1. And then if we go ahead and actually multiply this out, 693 multiplied by 8 is going to be 5,544. And then on the denominator, 1 times 1 is going to be 1. So we know that we are going to have 5,544 of these quarter by quarter meter cubes that would fit inside of this rectangular prism. Now, while that's one method, here is another that you may find useful as well. So it's good to know both of these. Here's method 2. All right, so we already established earlier that the volume of the rectangular prism was going to be 86 5/8 meters cubed. We figured that out in the very beginning. So this is the volume of the entire cube. We also figured out the volume of one of these itty bitty quarter by quarter meter cubes. But let's see if we can figure out using a different method, which is not going to be dividing their volumes, rather seeing how many of these cubes fit in each of the dimensions. Let's start by seeing how many of these little quarter by quarter meter cubes are going to fit across the length over here, just stacking them side by side. So to see how many times the length of one of these cubes, which is really just going to be 1/4 of a meter, see how many times this 1/4 fits into this 5 1/4, we'll figure out how many could fit along the length. Okay, so let's go ahead and take this 5 1/4. Now, if we know we're going to be dividing, let's just turn it into an improper fraction right away. So that's going to be 21/4. Let's go ahead and take that and divide by the length of just one of these, which is going to be 1/4. Okay, if we go ahead and do that, then we're going to end up with 21/4. And we're going to go ahead and multiply by the reciprocal. So we're going to multiply this by 4/1. If we go ahead and do that, then these 4s are going to cross cancel with each other. They're going to both become 1s. And then we're going to find out that we can fit 21 of these little cubes going across the length here. So that's how many little cubes are going to fit across this rectangular prism, because there are 21/4 inside of 5 1/4. Now, what about the width? The width is going to be this measurement that's 6 meters long. So we want to see how many of these cubes that are 1/4 meters in terms of their width, how many would stack across this side length that is 6. So rewriting 6 as a fraction, that's going to be 6/1. To see how many of these quarters are going to fit inside of it, let's divide it by 1/4. If we do that, we can rewrite this as a multiplication problem. So we're going to write 6/1 and multiply that by 4/1, the reciprocal. And if we multiply 6 by 4, that's going to be 24/1, which is just 24. So we're going to be able to fit 24 of these cubes along the width there. Now, what about the height? How many of these little cubes could we stack up and down the height here? Well, we got to figure out how many of these quarter length meters are going to fit inside of this 2 3/4. So they have the same denominator, so this should work out pretty nicely. Now, instead of writing 2 3/4, let's just go straight to an improper fraction. So I believe that is going to be 11/4, so 11/4. And if we want to see how many of these quarters fit inside of it, let's go ahead and divide it by 1/4. Again, for a third time, we're going to keep change and flip. So this is going to be 11/4. And then we're going to multiply it by the reciprocal of 1/4, which is just 4/1. And we should see some nice cross canceling here just because we have common denominators. So that 4 and 4 are going to cross cancel. And if that happens, then we're just going to be left with 1s. And then so we're going to end up with just 11/1 or just 11. So how would we use these three numbers to figure out the total number of cubes? Well, it looks like along the bottom we could fit 21 across the length, and then we can also fit 24 across the width. So If we multiply 21 by 24 here, that'll tell us how many are on the bottom layer of this prism, but then we're going to have 11 layers of this. So if we multiply 21 by 24 and then multiply that by 11, surprise, surprise, you can go ahead and do that long multiplication out, but you're going to end up getting that this is going to be 5,544. And so hopefully that confirms for us that we can use both of these different methods to think about it in a slightly different way, but also be able to conceptualize that we can find the volume of this rectangular prism and find out the number of cubes that go inside of them that fit perfectly. So that just about wraps up this video on figuring out the volume of a rectangular prism and seeing how many of these little fractional edge length cubes fits inside of it. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.